All right, this video is going to be about surface area and volume. And so I'm going to be looking at the first, let's see, 2, 4, 6, 8, 9 learning targets because they all really go together. So I'm just going to do them all at one time. And so the first thing that we need to know is that the surface area of a cell is the cell membrane. And that's going to serve as a door in and out of the cell. So we could say it's also known as the doors in and out of the cell. The volume is going to be your cytoplasm, but if you'll remember, your cytoplasm is your cytosol and all of your organelles. And so this is going to be all your needy stuff. So that chloroplast is going to need oxygen, and that mitochondria, not oxygen, water, and that mitochondria is going to need oxygen and glucose, and the lysosomes are going to need proteins. And so your parts of your cell are just always needing stuff. So that's your needy little boogers there that want everything. And so they're yelling at the cell membrane, hey, I need more glucose. Bring in more glucose. Because because the cell membrane is the door by which glucose gets into the cell. If you don't have enough surface area, you can't get things into the cell fast enough. And if you can't get things into the cell fast enough, the mitochondria is going to die, the chloroplast, whatever it is that needs that stuff is not going to have what it needs to do its job, and it could die. And then if the organelles die, then the cell could die. As a cell grows, so as a cell gets bigger, what we see happening, and you can do the math if you don't believe me, you can pick two cells, one smaller and one larger, and do the math. The volume grows faster, I can't write and talk at the same time, than the surface area. So as a cell gets bigger, they're both growing, of course, but the amount of volume is growing faster than the surface area. And so you're getting more needy things faster than you're getting more doors, okay? And so that's why you want to make sure that your surface area is adequate for your volume. You want to make sure you've got enough doors so that everything that your needy little boogers need can come in. Now, if a cell gets too big, so this is a big old guy here, it's going to go down one of two pathways. It's either going to die because it's just inefficient and unhealthy and it can't get things in fast enough, or it's going to go down a different road, and this is what most cells do, where it will divide. When it divides, that takes that big cell and turns it into two smaller cells. And that's going to increase its surface area to volume ratio, and that's going to make it more efficient or healthier. So let's look at some examples. So down here we have three different cells, a cube, a sphere, and a rectangular solid. Shape doesn't really matter because what really matters is our surface area to volume ratio. So for this one, we're going to do 6. Surface area of a cube is 6 times each side squared, because that's going to give you the area of one side. And because they're all the same, because it's a cube, you just multiply that by 6. And so 3 squared is 9 times 6 is 54. Okay, so that's 54. Of course, you would want to, if this is a free response, you'd want to use your units, 54 centimeters squared. 3 cubed, 3 times 3 is 9 times 3 is 27. And that's going to be centimeters cubed. Surface area is always going to be squared, volume is always going to be cubed. Okay? And that's going to give us a surface area to volume ratio of 54 surface area to 27 volume. Okay, I'm going to leave that there for right now. All right, coming over here to our sphere, we have 4 times pi times 2 squared. Okay, 2 times 2 is 4. 4 times 4 is 16. 16 times pi, I don't have room, I didn't plan this very well as far as setting it up, is 50.27. 4/3 pi 2 cubed. 2 times 2 is 4, times 2 is 8. So that's going to be 8 times 4/3 times pi, and I've already done this just in the interest of time. That's going to be 33.51. If you don't trust me, you can pull out your calculator and double check. And for the ratios, we're just going to round these. I know that's not how chemistry does things, because everything's got to be real precise. But for us, for biology, it doesn't have to be quite as precise when we're doing something like this. There are times that precision matters. This is not one of them. So I'm going to round surface area down to 50. And my volume, because that's above 5, I'm going to round, or it's 5 or above, I'm going to round that up to 34. So that one is going to be 50 to 34. Okay. Hang tight there. All right. for my rectangular solid, to find my surface area, and again, surface area is if you were wrapping this box like a present, how much wrapping paper would you need? Okay, so I need to find the area of each end, and there's two ends, so I find the area of one and multiply it times 2. I find the area of the front and the back, multiply that times 2, and I find the area of the top. I can get my hands where I need them. Boop, 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 boop. There we go, top and the bottom, and I multiply that times 2. Okay, so that's what all this mess is. So 2 times the length, and I just made it easy on myself. Length, width, height, 2, 3, 4. So length is 2, width is 3, plus 2 times 3 times 4, plus 2 times 2 times 4. All right, 2 times 2 is 4 times 3 is 12. 2 times 3 is 6 times 4 is 24. 2 times 2 is 4 times 4 is 16. And we'll put that over here. 12 plus 24 plus 16 is 52. Okay, volume, a whole lot easier. Length times width times height. So 2 times 3 is 6 times 4 is 24. Okay, so this one is going to be 52 to 24. Okay, well, eyeballing these, I can't really tell you because they're all different numbers which one has the better surface area to volume ratio. Easiest way to do that is to divide both sides by the volume. Okay, so 34, 34, and this one is 24, 24. Okay, so I'm just dividing for each ratio, I'm dividing it by the volume. That's going to bring my volumes all down to 1 because anything divided by itself is 1. And so now that my volumes are all equal, then I can really compare my surface areas a little bit better. So 54 divided by 27 is 2. It's a nice even number. 50 divided by 34 is 1.47. I'm just going to round that to 1.5. And then 52 divided by 24 is 2.17. So I'm going to round that to 2.2. All right, now I can compare them. So I know by looking at these, this one compared to the volume has the most surface area. So this would be the healthiest cell. So we'll give him the gold ribbon, or the gold medal, sorry, gold medal, blue ribbon. So he's number 1. So if the question said rank these cells from healthiest or most efficient to the unhealthiest or least efficient, that would be number 1, this would be number 2, and this would be the unhealthiest or least efficient cell. So I can explain why a large surface area to volume ratio is beneficial. Okay, that's because you need more surface area to get all of the things in that the cell will need. I can define surface area of a cell membrane. I can define the volume of a cell, that's the cytosol and all of the organelles. I can calculate surface area for a shape when given the formula, and you will be given all of these formulas. This is your beautiful little formula sheet, so you've got your surface area and volume for these 4 shapes, and so that's what they would use, and it even tells you over here, you know, what all the abbreviations stand for. So I can calculate surface area and volume for the shape when given the formulas. I can calculate the surface area to volume ratio. That really shouldn't say calculate. I can set up, because you're really just taking your surface area and your volume and putting them surface area first next to volume. I can reduce the surface area to volume ratios so that I can pair them. That's where we went and divided by the volume. Got them all the same. All the volumes were the same. I can describe what happens to cells. I can use the reduced surface area to volume ratios to compare the health of the cells. So we would again say this is healthiest because it has the most surface area, second and least healthy because it has the least surface area. And then I can describe what happens to cells that get too large. They're either going to die or they're going to divide. So that is your first, I think I said 9 learning targets, all dealing with surface area, volume, cell size. I hope that helps. If you have any more questions, just let me know.